Okay, it's been about a year now, and this crude but understandable device becomes the backup to the backup, which is now a fully operational battery backup system for the sump pump. Includes this power inverter up top, power inverter charger, which will take AC power and pass it directly through to the pump underneath the lid down there. And the pump comes on as needed when the float reaches a certain height. In the absence of AC power, i.e. a storm or a power outage, it will automatically cut over to battery power and invert it or convert it to AC power to run the pump again. So the pump has got continuous supply of power the way it needs it. And when the AC power comes back on, it will switch back the other way and charge the battery. So really, self-contained system should work by itself. How much protection we have? Haven't a clue. We're going to find out by doing some tests. The power inverter charger I got from where else? eBay. Everything else I sent away for, including there's a fuse down there that goes between the positive line and the battery positive terminal. Marine type fuse, which doesn't require splicing in the line. It just bolts onto the terminal, so that was kind of neat. The table I built from wood around here. The bottom part of the table is actually from something I built for my motorcycle, and that's a good thing because I cannot believe how heavy this battery is. Anyways, we're going to test it out and see what we got. Brought the hose in through the window here. We're going to put it through the drain and cause the sump pit to fill, invoking the pump, which for the first cycle we'll let run on AC power. Then when it cuts out, that will be this. When the pump cuts out, that will be the start for the testing. So we'll invoke battery only by tripping this switch and see the duration of each pump instance and how frequently it comes on in a time period. Say, I don't know, half an hour. We'll see how many times it comes on, and what happens to the battery indicator here. So if the battery indicator goes down to say 30%, we'll have a rate of discharge anyways. There we go. There is some link between that drain and the sump pump, but I couldn't find it, so I'm just going to dump it through the top lid here. Of course, I forgot to disconnect my homemade water alarm, and it cut in. At least it's still working. This is a jogging alarm that I rigged up to be a high water alarm. Pump has not cut in yet, so I can't start the test. At this rate of hose, it is coming on about every 5 minutes and staying on for a minute, and I still do not see any battery degradation. It's still green on the left, and that means it's above 90% battery. Of course, I told Kate to turn the hose on full, and she doesn't remember if she turned it on full, so I'm going to have to check that afterwards. This is getting so predictable, I might be able to go get another coffee before the next cut-in. Still no indication of battery drain below 90%, and I think I've filled the ditch in front of the house, so I don't know, I might have to cut this test short. This ground fault circuit interruption GFCI protection installed by Patrick here. He put this new outlet here and had both of them covered by that. Not sure exactly what that is, but I still don't trust anything around here. When it comes to electricity, I'm going to make sure I have a plastic bag over my hand. So, after studying all this scientific data, it seems that we have 1 3/4, maybe 2 hours of standby run time on a 100 amp hour battery running or supplying as needed a 515 watt sump pump. Don't quote me on it, but tell you what, it's a heck of a lot more protection than I used to have. Here's a technical footnote to the whole test, which I'm sure glad I learned. All during the DC only portion of the test, i.e. when we're drawing from battery, this left indicator is the battery indicator showing fully charged. Well, all during the test, it continued to show fully charged, and I'm thinking, wow, this battery is a super battery. It hasn't even lost power. Still within 90 to 100% of full capacity after an hour and a half. Only when I put the AC power back on did this refresh or update, and it went red, of course, meaning battery consumption. I then, to guess or estimate the amount of consumption, looked at the charge rate of the inverter there. Charges at 20 amps. Is the charge rate, so it took 50 minutes to recharge, so maybe 17-20% of the battery was consumed. But it's sure good to know that you don't rely on that thing while it's on DC power to give any kind of indication of how much battery is left. Good to know. Okay, screw all the testing and measurements. The simple fact is that the sump pump puts its output right here. Okay, it rained. It's not all from the sump pump. But this side, considerably drier. We have some protection here.